Hi everyone. In today's video, we will solve the Chemistry JEE Mains 2020 Model Question Paper 2. We have already solved one model question paper of JEE Mains 2020. So today we will go to the next model question paper. Okay. So as you know, from first question to 25th question, the questions are based on physics subject, and from 26 to 50 the questions are based on chemistry subject. So the 26th question and the very first question in the chemistry subject is 4.0 gram of NaOH are contained in 1 deciliter of solution, then its molarity would be. So they asked you to calculate the molarity, and here molarity, it can be calculated by the formula number of moles of solute to the volume of solution in liters. Volume of solution in liters. Okay. Now here number of moles, how you will calculate? The given mass divided by molar mass, let us call it as M1, and volume of solution in liters, so divide it by 1000. Okay, because usually here the volume is given in ml, so we will take it as V divided by 1000. Then how much you will get? W into 1000 divided by m1 into V. Okay, that is the molarity. So first write down the given things. They have given the W, given mass, that is 4.0 gram, and contained in 1 deciliter. So 1 deciliter, that is volume. 1 deciliter is equal to how much? 100 ml, or you can say 0.1 liter. And now M1 is also given, molecular mass of NaOH. It is not given, but the NaOH, its molecular weight should be known, that is 40 gram. Or you can calculate, the Na is 23, so oxygen is 13 and hydrogen is 1. So totally its molecular mass becomes 40. Now substitute these values in this equation. You will get how much? M is equal to, W is 4 into 1000 divided by M1 is how much? M1 is 40 into given volume is 100. So how much you will get? You will get 4 into 10, 40 divided by 40. So you will get 1 m. That is the answer. So the molarity of the solution is 1 m, and it is option 1. That is the right one. Next, 27th question. In a blast furnace, the highest temperature is in combustion zone, fusion zone, slag zone, and reduction zone. As you all know, in combustion zone, okay, the combustion of coal or coke will take place, and hence the temperature is high at combustion zone because it is resides at the bottom of the blast furnace. And as we go in the upper region, we will find fusion zone, slag formation zone, and reduction zone. In reduction zone, you will find the lowest temperature, and hence since they have asked here to know highest temperature, hence combustion zone is having the highest temperature in blast furnace, that is around about 1800 to 2100 Kelvin. 28th, the disperse phase in colloidal iron hydroxide and colloidal gold is positively and negatively charged respectively. Which of the following statements is not correct? 1. The mixing of sol has no effect. Magnesium chloride solution coagulates the gold sol more readily than the iron hydroxide sol. Sodium sulfate solution causes coagulation in both sols. Coagulation in both sols can be brought about by electrophoresis. So among these 4, the second, third and fourth statements are correct. But the first statement, that is mixing the sols has no effect, it is not correct, because when we mix the positively charged and negatively charged collide, then the coagulation will take place. And hence option 1 is, the statement given is not correct, and hence the answer is option 1. Okay, the option 1 statement is not correct. 29th, diethyl ether is not associated with which one of these isomers? So diethyl ether, how you will write it? C2H5OC2H5. Okay, so it is not associated with which one of these isomers? Okay, and what is its formula? C4H10O. Now see one by one. The butanoic acid, what is its formula? CH3, CH2, CH2, COOH. So how you will write the formula? C4H8O2. But what is the molecular formula of diethyl ether? C4H10O. So option 1 is not correct. Then the second one, methyl propionate. How will write the methyl propionate? CH3, CH2, COOCH3. Okay, and molecular formula is C4H8O2. This is also not same. And stereoisomerism, the diethyl ether, it is a positional isomerism, and hence it does not show a stereoisomerism, and hence among these four, the fourth option is right, that is none of this. It is not associated with any one of these, and hence the fourth one is none of these. 30th, sugar of lead is. The sugar of lead is written as CS3COO twice Eb, that is lead acetate. The lead acetate is said to be sugar of lead, and hence the option 1 is the right answer. 31st question. The rate constant of a reaction at temperature 200 Kelvin is 10 times less than the rate constant at 400 Kelvin. What is the activation energy of the reaction? So what is the formula that you know? Log K2 divided by K1 is equal to EA divided by 2.303 RT log T2 minus T1 divided by T1 T2. This is the formula that you have. So first write down what they have given. K1 and K2 you should know. So K1 is the rate constant at temperature 200 Kelvin, that is T1 is equal to 200 Kelvin, and K2 is rate constant at temperature 400 Kelvin, therefore T2 is 400 Kelvin. So K1 is less than the rate constant at K2. So let us consider K2 as K and K1 as K divided by 10, because it is less than the rate constant at temperature 400 Kelvin. If it is K, then it is less than 10 times of that of the K. So K divided by 10. Now substitute the values. What you will get? Log K2 is K, K1 is how much? K divided by 10 is equal to EA divided by 2.303 R. Sorry, this is not T. So log T2 is how much? 400 minus 200 divided by 400 into 200. Okay, so simplify this. What it becomes? Log 10. K get cancels, 10 comes here. Log 10 to the base 10. Okay, EA divided by 2.303 R log 400 minus 200, 200. So 400 into 200, the 200 into 200. So 200 get cancels. What will remain? So you will get 1 is equal to EA divided by 2.303 R log of 1 divided by 400. So simplify this. Upon simplifying, you will get EA is equal to 921.2 R. This is the answer. So option third is the correct one. 32nd, the last member in each period of the periodic table is. So last member in each period of the periodic table. Is it an alkali metal, an inert gas element, a halogen, transition element? You know, 18th group is the last group, and last element in the period. As we move along the period, the last element will be an 18th group element, which is a noble gas or inert gas, and hence option 2 is an right answer. An inert gas element you will get. Next, 33. Orthonitrophenol is steam volatile, whereas paranitrophenol is not. This is due to orthonitrophenol. How you can write it? Orthonitrophenol. Okay, this is phenol. Ortho position, NO2 group is there, and it is steam volatile. Okay, steam volatile means upon simply heating it will get volatile, it will get evaporated. But paranitrophenol is not. So paranitrophenol, how you will represent? OH, and at para position you will find the nitro group. So orthonitrophenol is steam volatile, whereas paranitrophenol is not. It is because it will form steam. It does not form, it will directly gets converted into gas, but it will form this steam when we heat because of presence of hydrogen bonding. Due to the presence of intramolecular hydrogen bonding, it will undergo steam volatile. So hence the answer is option 2. Intramolecular hydrogen bonding is present in orthonitrophenol because hydrogen and nitrogen oxygen both are electronegative. So here the hydrogen bonding is formed between hydrogen and oxygen, but here the nitro group is at different position and hydrogen, which is hydroxyl group, is present at different position. So the bonding is not possible. Hence option 2 is the right one. 34th, due to covalent bonding, the transitional metals are what they will show? They are ductile, hard and brittle, conductor, lustrous. So transition metals are hard and brittle because of covalent bonding. For example, you can take the silicon carbide and diamond and graphite. All these are, graphite is soft, but other elements are hard and brittle. 35th, propene on treatment with HBr gives. So when propene it is treated with HBr, so how we can represent the propene? CH3, CH double bond, CH2. So this is the propene. When it is treated with HBr, what is the major product here? Isopropyl bromide. So isopropyl bromide will be formed. Okay, so that is the right answer. Option 2 is the right one. 36th, which of the following is not a water absorber and dehydrating substance? So water absorber, when you see this, concentrated H2SO4 is dehydrating agent, aqueous CaCl2 is absorber, P2O5 is also absorber. Silica gel is not absorber, but it is adsorber, and hence option 4 is the right answer. 37th, which of the following can act both as Bronsted acid and Bronsted base? So among these OH minus, it is Arrhenius base, H3O plus is acid, and HCO3 minus, here this H3O3 minus, it will act as both Bronsted acid and Bronsted base. So HCO3 minus will act as both Bronsted acid and Bronsted base. So what is Bronsted acid? It is the species which is able to donate H plus ion, and Bronsted base means it is the species which is able to accept H plus ion. So this one can do both the things, and hence HCO3 minus act as Bronsted acid as well as Bronsted base. 38th, phosphoric acid is preferred over sulfuric acid in preparing hydrogen peroxide from peroxides due to, because H2SO4 acts as a catalyst for decomposition of H2O2, hydrogen peroxide, and therefore some weaker acids like H3PO4, okay, and H2CO3 are preferred over H2SO4 for preparing H2O2 from peroxides, because H2SO4 acts as catalyst for decomposition of H2O2. Hence, it will be not used, and hence option 3 is the right answer. Since it acts as a catalyst, it is not used. The other compounds are preferred instead of the H2SO4. 39th, CH3MgI is an organometallic compound due to, is because of simply, CMg bond. Okay, so due to the formation of CMg bond, the presence of CH3MgI is possible, which is a Grignard reagent. So option 2 is the right answer. Then 14th, the IUPAC name of CH3C triple bond CCH CH3 twice is, simply follow the rules, you will get 4-methyl 2-pentyl. 4-methyl 2-pentyl. Triple bond is there, so YNE you will use 5 carbon atoms, 1, 2, 3, 4, 5. So therefore the number of carbon atoms is pent and YNE, and double bond is present at second position, name from this side 1, 2, and hence 2-pentyl, and at fourth position 1, 2, 3, 4, at fourth carbon the CH3 is there, hence we will write 4-methyl. Therefore the option 1 is the right one. 21st, which of the following statement is false? Clean water would have a BOD value of less than 5 ppm. This is the correct statement. Okay. Then concentration of DO below 6 ppm is good for the growth of fish. No, this is the wrong statement, because the ideal value of DO for growth of fishes is 8 mg per liter. Okay, and below this value fishes get susceptible to disease, or if it is having the value 2 mg per liter or below it, then it is harmful to fishes, and hence the option 2 is the right answer. Okay, the statement is wrong and hence it is the right answer. 42nd, for the reaction H2I2 gives 2HI, the equilibrium concentration of H2I2 and HI are 8.0, 3.0 and 28 mole per liter respectively. The equilibrium constant of the reaction is, so Kc is equal to, how you will write, HI is the product, okay, concentration of product, 2HI there, so square, and divided by product of concentration of reactants, that is concentration of H2 and concentration of I2. So HI value is given, that is 28.0 mole per liter. Substitute that, 28 square divided by H2 hydrogen value is 8 into I2 is 3. So how much you will get? Upon simplification you will get 32.66. So the answer is option 3, 32.66. 43rd, in which of the following compounds the oxidation number of carbon is maximum? So simply if you see in HCHO, what is the oxidation number? In HCHO, the oxidation number will be 0. And in CHCl3, the oxidation number is +2. And in CH3OH, the oxidation state is -2. And in C12, H22O11, the oxidation number is 0. Therefore, the carbon is having highest oxidation number in the case of CHCl3. So option 3 is the right one. 44th, electrode potential of Zn plus 2 bar Zn is 0.76 volt, that is minus 0.76 volt, that is Zn plus 2 bar Zn is equal to minus 0.76 volt, and that for Cu is Cu plus 2 bar Cu, that is equal to plus 0.34 volt. So here they asked you to find the EMF or cell potential. How you will calculate? E naught cathode, okay, and minus E naught anode. Cell potential can be calculated by using this formula. So now at cathode, which one you will take? The one which will undergo reduction. So here Cu plus 2 is converted into Cu. That means it has taken the electrons, so it will undergo reduction. Therefore, you need to take the value of copper, that is 0.34, minus anode, so minus 0.76. So how much you will get? 0.34 minus into minus plus 0.76. How much you will get? 1.10 volt. It is also plus. Therefore, option 4th is the right answer. 45th, addition of HI on double bond of propene yields isopropyl iodide and not N-propyl iodide as the major product. This is because the addition proceeds through. Just see the reaction. HI, hydrogen iodide, it will give H plus and I minus. Now, when it is added to propene, that is given as CH3, CH double bond, CH2. It is propene. It reacts with the H plus to give CH3, CH3, CH2, CH2 plus along with this another carbocation will be formed, that is CH3, CH, CH3 plus. Now here it is primary carbocation, this is secondary carbocation, okay, and you know that secondary carbocation is more stable. Secondary carbocation is stable as compared to primary. If we consider tertiary, then tertiary carbocation is more stable than these two. So here the secondary carbocation will be formed, and hence here the addition will take place at this position, okay. I will come here, and therefore due to the formation of more stable carbocation, or you can say carbonium ion, the major product formed will be isopropyl iodide. 46th, copper crystallizes in FCC lattice with unit cell edge of 361 picometer. Dash picometer is the radius of copper atom. So they have given FCC, and you should know the relationship between edge length and the radius. That is A is equal to 2 root 2 R, where R is radius, A is edge length. Edge length is already given, so R is equal to, you need to calculate radius. So A divided by 2 root 2. A is how much? 361 into 10 raised to minus 10, and 2 root 2. How much you will get? You will get 127.633 into 10 raised to minus 10, 10 raised to minus 10 meter, or you can say 127.633 picometer, or it is equivalent to 128 picometer. So the correct answer will be 128. 128 picometer is the radius of copper atom. 47th, amongst the species given below, find the total number of diamagnetic species: H atom, NO2 monomer, O2 minus superoxide, dimeric sulfur in vapor phase, Mn3O4, NH4 twice FeCl4, NH4 twice NiCl4, K2MnO4, K2CrO4. So in this structure, you need to find the total number of diamagnetic species. Here you can see, first one by one you can see. First take down K2CrO4. K2CrO4. Here the central metal atom is Cr, and its oxidation state will be +6. Okay, and hence all are paired electrons. It can be given as Ar3d0. Okay, since all the electrons are paired, here it is a diamagnetic species. Diamagnetic species. Next, in case of hydrogen atom, okay, hydrogen atom electronic configuration is 1s7, and hence unpaired electron is, so it is paramagnetic. Okay, and then NO2, here the structure is given like this: N plus O minus double bond O. So itself it consists of odd number of electrons, and hence it is also paramagnetic. Then you can take O2 minus. Okay, so O2 minus has one unpaired electron. Okay, and hence it is also paramagnetic. In the similar manner, S2, Mn3O4, okay, all those are having the unpaired electrons, hence all these are paramagnetic in nature. So simply go on finding the number of unpaired electrons, then you can easily get the answer. So except K2CrO4, all are paramagnetic. Only K2CrO4 is paramagnetic. 48. A student performs a titration with different borates and finds titrate values of 25.2 ml, 25.25 ml and 25.0 ml. What is the number of significant figures in the average titrate value? So average titrate value is 25.15. How you will find it? 25.2 plus 25.25 plus 25 divided by 3. If you take the average, you will get 25.15. But the number of significant figure cannot be greater than the same in either of them being manipulated. Okay, and hence here these three are significant figures in the average titrate value. So the significant figures in this will be 3. 49th. In a certain process, 1000 joules of work is done on the system, which gives off 100 calories of heat. The value of delta E for the process is. So delta E, how you will give the equation? Delta E is equal to Q plus W. So now Work is given in 1000 joules. Okay, but Q is given in calories, and therefore you should know 1 calorie is equal to how many joules. So 1 calorie is equal to 4.184 joule. Convert this into joules. How much you will get? How you will convert that? Q is equal to 100 into 4.184. 4.184. It gives 418.4 joules. So solve this. Delta E is equal to Q is minus, because it gives off, so exothermic, so minus 418.4 plus 1000, because work is done on the system, so it is 1000. So what we will get? Plus 581.6 joule. This is the delta E value. Then 50th, if ionization potential of hydrogen atom is 13.6 electron volt, the ionization potential of He plus is. So how you will solve that? Ionization potential IP of hydrogen atom. Okay, hydrogen atom is equal to minus E1. That is how much? Minus 13.6 electron volt. And ionization potential of helium atom, that is He plus ion, is equal to E1 into Z square. So 13.6 into 2 square is equal to 54.4 electron volt. So remember this formula, E1 into Z square. By using this, you can find the ionization potential. So this is all about the JEE Mains 2020 model question paper. Solve some more questions and some more question papers. It will be very helpful for you. Thank you.